In ancient history, creating software involved a lot of manual labor. We would invoke compilers by hand, run tar on a bunch of compilation products to package them up, and maybe more sophisticated engineers would hand wire dependencies in a makefile. And maybe some of us still do. But for me at least, that's a lot of manual labor. So eventually along came the IDE, which offered an interface for the whole software development lifecycle, from editing, formatting, refactoring, structure, giving you a structure for organizing your code into modules and projects and workspaces, to building, running, testing, debugging, packaging, deploying, all at the click of a button. Now, buttons are great. That's why I work on a tool that has lots of buttons, the IntelliJ plugin for Scala. Excuse me. So, yeah, I'm Justin. You can also find me on Twitter as Ebenwert, and you can find our team on Twitter as IntelliJ Scala. So, if you have any comments during or after or at any time that before the presentation, you can direct them there. All flames, please go to our team account. So just out of interest, who of you uses IntelliJ for Scala development? Yeah, that's, I think, most of you. Cool. By the way, who knows that we're on GitHub? Like, most of the Scala plugin is on GitHub, free for you to work and derive. That's like, okay, that's a few, but now it's all of you. So if you're ever unhappy with what we produce, you can just clone it and change everything. And we even take pull requests. So now to the purpose of this talk. It says build server protocol and beyond, and integrating developer experiences. I'm going to talk about a bit what that means to me. And I'll give you an approach of integrating these experiences, namely the build server protocol, which aims at integrating build tools into the IDE or other tools. And I'll give some specifics of the BSP implementation in the Scala plugin. So I mentioned buttons. They're fun and all, but some of us want a more bespoke experience of how we build, compile, manage our projects, and we want to be able to use it in a variety of environments, not only in the IDE. We want to run it on a CI server. So typically for that we have build tools. Build tools in turn integrate several other functionalities such as dependency management and test frameworks. And they have the advantage of being cross-platform, and you can run them from a command line, which is a fairly portable interface and programmable. But it's not a very easily integrated interface. You have a lot of interface mismatch. You see these faces, they really don't fit that well. They have, all of these command line tools have like idiosyncratic configurations. They often have strange differing syntaxes, input formats, output formats. So what we've often done in integrating tools into the IDE, because the built-in IDE tools are also nice, but you want to work with the ones that you use on the command line as well from the IDE, such as Scala test and specs. So they have command line runners, and for each of them we would write a specific integration that calls a command line runner with specific arguments and so on. We have build tools such as SBT, which I have been working on a lot, the SBT integration into IntelliJ. And that's a bit of a mess because I had to create a special plugin to export the build structure, special code to map the SBT structure to IntelliJ structure, project model, and another plugin for the shell integration, just so we can know has a task that I sent to the shell actually been executed. And that doesn't even give you a nice compiler output yet. And so SBT is the most popular tool, but in Scala we have more choices than that. Like every few months somebody is unhappy with a status quo and comes up with a new one. Ideally I'd like to support them all, but the experience has taught me that with SBT, yeah, I could maybe support one more build tool. So, and if there's no clear contender for the second place, which one do I choose? So, yeah, we have a bunch of build tools and a lot of lacking coherence in how to work with them. And there would be several manual steps in the workflow, like exporting a build to the IDE from the terminal. If you want to do a build, switch back to the build tool or do it from IntelliJ. It's lots of context switches that get you out of the flow. So we have, yeah, this haphazard tangle of tools. You need 4 arms just to use them all at once. So I've been working on trying to tie these loose tooling threads and create a more integrated developer experience. But first, let's have some look at some prior art. You may have heard of the language server protocol. So some background on that. In IntelliJ and many other IDEs, we rely on custom language integrations for each language that we support for various reasons. So this language server protocol, or LSP for short, was developed by Microsoft for their VS Code editor to make it easier to write integrations for the editor with language servers, which are basically wrappers for a compiler, and you know, give a standard way for an editor to communicate with it. So this language server protocol has been quite successful, actually, and so successful that people keep asking us if we're going to use it for IntelliJ. Because for many people, like, red squiggles in the code have been a bit of a pain point for a long time. And if you integrate directly with the original compiler, that would make that easier. But for various reasons, we can't really do that because all our other features rely on our internal representation. But we might still integrate with the closer with the compiler, especially for Scala 3. Another challenge is that, like, this LSP doesn't really model the structure of the code base. It's left to the language server to interpret a file tree as a project tree, how it does it. And there's no common concept of, like, some actions like build, test, run. In LSP, the editor just says, hey, I modified some file, language server, do you want to do anything about it? So it might compile and give you a bunch of error messages, or might do something different. And we have in IntelliJ a bunch of actions that are more user-directed. And yeah, I mentioned the syntax tree. That's really the major thing for us. So, I said every few months a new build tool emerges from the sand. Let's take as an example Fury, which has been trying to emerge for quite some time, but there's a lot of sand around it. So, but I'd still like to support the experimentation in the build tool space to make new approaches possible, but still have a good experience working with these tools. So that means support in the IDE, which many of you use. Now I can't quite justify investing the time to support each tool specifically, like given that Fury has a limited user base of approximately 2, and it would increase my complexity and maintenance load by quite a bit for each build tool that I add, because each tool is kind of different. So one option would be that the developers of Fury contribute some kind of IntelliJ support, like export to the IntelliJ model. But like John, who invented it, doesn't even use IntelliJ, so he's maybe not sufficiently motivated. But I want to open it anyway, you know, kind of like this, open. And let's see what happens. Oh, sorry. And it opened in the other window, of course. But here we go. We've got Fury opened, and we can look at some sources. Looks kind of nice, yeah. It even gives us all kinds of warnings, type hints, so it seems to be imported correctly, give or take. So yeah, I can already use Fury with IntelliJ. Now, how did I do that? Simple enough, I implemented the build server protocol, or at least a subset of it, into Fury, and I implemented client-side support of the build server protocol into the IntelliJ Scala plugin. So, and this approach will work for many other build tools as well. I'll get around to what the BSP ecosystem currently looks like. I was kind of inspired by some quote, allegedly by Abraham Lincoln, who said, "Give me 6 hours to chop a tree, and I will spend the first 4 sharpening my axe." I said, yeah, give me 6 weeks to support a build tool, and I will spend the first year implementing a protocol. So you can see it kind of worked out. Side note, Fury is an interesting case because it's both a BSP client and a server. So it's a server towards IntelliJ and a client towards Bloop, which I will mention. So now, what is this build server protocol thing? It's a protocol that extends and complements LSP in a way. So it's based on the same base protocol, which is a JSON RPC client server protocol. And just like LSP integrates language servers, compilers, and editors, BSP integrates build tools and IDEs or language servers. So one model that it was initially developed for by people from the Scala Center is for the Metals language server, as to use any build tool such as SPT as a backend for the language server, which in turn talks to the editor. But I found that this exactly addresses my problem as well of integrating build tools with the IDE directly. So unlike LSP, BSP has a concept of a project model and some actions on this model. So common operations such as build, test are exposed as endpoints, JSON RPC endpoints, where you can just do a request. And they have like standard semantics, things that you can expect from them. So, as I mentioned, it's a client-server protocol with a specialty that it's bidirectional. So, in principle, both the server and the client can send requests, but it's always the client that initiates the connection initially. And most of the time, also, the client is the one that sends the requests. And there's notifications, which are basically just one-way messages that don't expect a reply. And most of the time, it's the server that sends notifications. One expansion upon LSP that makes it much easier to integrate with tools even without having any special support for each of these tools is the server discovery protocol. It's very simple. So I want to connect as IntelliJ to some build tool, but I never heard of this build tool. I haven't programmed any special support for it. And the build tool author, that's because like the build tool author just invented it, but the author wants to work with IntelliJ right away. So what the build tool does, it writes a connection file. Oh, non-straight wall. A connection file to a specified location, usually in the project workspace, but it can also be in special locations on the user's system. And when I start IntelliJ and want to import this project, I just look into this workspace, look for this connection file, and that file specifies how to start the tool. And after that, everything happens over a standard protocol via standard in, standard out. Like it's very simple. JSONs get written to standard out, or JSONs get read from standard in. That's all there is to it, but that makes it so much more flexible than even LSP in this regard. Now, here's a very nice and clean project model. It's closely modeled after Bazel, for instance. We have a bunch of targets. These are roughly equivalent to modules in IntelliJ or projects in SBT. And they encompass a bunch of settings like metadata capabilities, like can you test or compile this, some language-specific data, like maybe JVM or Scala library, and dependencies on other targets. And then associated with targets, you have sources. So one set of sources can be associated with multiple targets, or likewise, one target can have multiple sets of sources, individual files, or different directories. And within a target, all the sources get compiled together. And they can be, and then the compilation products can be fed in as dependencies to other targets' compilation. Now, when you want to run a compile, there's a request for that, build target compile. In this request, you just specify a bunch of targets that you want to compile, or could be all of them, or just one. And eventually you'll get a compile result. This compile result just tells you compilation has finished, there are errors or there are not. So if you want the actual errors, you gotta listen for the diagnostics. They are typically streamed during the compilation, so you can get live updates. And so you get a better idea of what's going on. You can also get progress messages that give you more detail. So, short note about diagnostics. They are notifications. It gets sent from the server to the client. They're typically warnings or errors. They can be sometimes purely informational as well, like you have a missing new line or whatever. These are exactly analogous to the LSP diagnostics data structure, so they're made to be compatible. The progress notifications, or tasks as we call them, are also typically sent during a compile or maybe a test request. Tells you, okay, I started compilation of some module. Then you get a bunch of progress notifications, like 10% completed, 100 files of 1,000 completed, and so on. And eventually a finish notification. Usually triggered by a request, but they may as well be sent independently because there's some background task running that you want to inform the user about. So, about IntelliJ Scala plugin as a BSP client. I want to show you a bit more how it looks. So, let me close Fury. I'll open Cats. So I imported Cats not as a SPT project, but as a BSP project, which works via Bloop, which is a compile server, which is currently the most complete implementation of BSP. And so I can run a quick compile here. You see, it was already all compiled, so we have just an incremental compile, which went very quickly. Let's see what happens when I introduce some kind of error here. I do recompile, and I very quickly get an output. Okay, there's something wrong here. Do you see that? You see, okay, not found, type B. Let's undo that. Oops. And everything compiles fine. I forgot to activate the excuse me. Oh, I just broke something. Never mind. See, yeah, we get very quick feedback over BSP about compilation errors, and we get a nice list. So that's an improvement over if you want to compile with SPT, and maybe even if improvement over compiling with a built-in IntelliJ compiler, which is also an incremental compiler, but has some overhead that Bloop works around mostly, so you can get faster compile feedback cycles. So one thing you see is you have all these check marks and you have timings. So if I were to do a full recompile, I gotta do this manually here via Bloop clean. Then you'll see timings going on. So this is definitely more informational what you get over other compile interfaces right now. So you have a better idea of where like your compilation bottlenecks are, because you see this by module. So this feature, as you can see, is available. It's been available since 2019 too, last year, with an upcoming 2020.1 release. I'm introducing a few more stability fixes, making it work more smoothly for most people. Currently, it's only supported in the Scala plugin of IntelliJ, and only really supports Scala targets, but that will change in the future, so we're aiming for a wider support. Quick rundown of what happens when I import a IntelliJ SBT project via BSP into IntelliJ. So some things we deal with is like in SBT, projects can have several scopes, compile tests, and even others. In BSP, targets do not have a scope. So what we do is we export, or what Bloop does, is export these scopes and projects into individual targets. So both in SBT and BSP, targets or projects can share sources. In IntelliJ, we have the restrictions that they cannot share sources, but we do have scopes, but only compile and test. So what we do is we map these scoped things back to these scope targets back to scopes in IntelliJ modules, but a shared module still needs to support. We need a shared module, synthetic source module, to support shared sources. It doesn't work perfectly, but at least you can represent your code somewhat. And that's sometimes where a lot of compilation problems come from when you try to compile an SBT build that you imported into IntelliJ with the IntelliJ compiler. So BSP is another way of working around that because the actual compilation then happens in the build tool. Short overview over the BSP ecosystem. So as clients, we have IntelliJ, Scala plugin, and Metals, and Fury's sort of in between, which can act both as a server and as a client. Otherwise, the major server is Bloop, which supports a variety of build tools such as SBT, Maven, Gradle, Pants, Mill. Because for all of those, it has a plugin that lets you export the build structure into the Bloop structure. And for Mill specifically, we developed a plugin that supports BSP directly. And there's work going on for Bazel and Pants to support BSP directly as well. And I know that BSP is in fact used in some larger organizations to support their internal build tools within IntelliJ. So I've gotten good feedback on that. So a short view on the BSP roadmap. The protocol version 2.0 is basically final. We just haven't formalized that yet. There's a bunch of build tools supporting it already. Supporting more tools is coming. And within this year, I'd like to bring the BSP support into the IntelliJ base distribution and thus support more languages and ecosystems. Now you can, since this talk is titled Build Server Protocol and Beyond, there's some space to think about what could happen beyond just supporting build servers. One interesting one would be remote building. So right now BSP is mostly geared toward building locally, but if you want to work on a lower end laptop, for instance, but still want to work on your huge corporate project, then that could be a very worthwhile integration, but maybe not as easy. BSP does have support for testing, but maybe there could be some more fine-grained requests that we can support. One major challenge is, besides if tools are actually similar enough to warrant protocol abstraction and develop a protocol, which is a fair bit of work. Most of the work is in fact in adoption, and that's one reason I'm here and talking to you, so you get a good idea of what this is about and if it could be helpful to you. And perhaps if you develop tooling, then it would be interesting to talk to you about that. So that basically concludes the presentation. In the slides, I have a few links to the BSP specification. There's libraries for Java and Scala implemented and a test kit. And there's a blog post I wrote which basically summarizes the info of this talk. So we have some time for questions, I believe. If you're too shy to speak, you can tweet at me.